my problems.
That's good. I'm glad he was able to fix it. These things are a pain sometimes.
Okay, should I share my screen or you want to share?
I can share mine.
Oh, perfect.
Yeah.
Okay, then I'll please now.
Right. Okay. Can you see my quiz?
Yeah, hold on.
Okay.
Hold on. I'm trying to open mine. Just give me a second.
No worries.
Quiz for what? 14?
Lesson 14. Yeah.
Group meeting quiz 14. Submissions. Okay, there. I'm looking for you now. Okay. Okay, I'm ready. I got them all right. I didn't have problems with this quiz. I had problems with the homework quiz, and I already took it twice. Did you take?
This is the first one I've taken thus far. I haven't. I'm pretty sure that I've got all these right. I just started going through it just maybe like an hour ago. But I only one I had a hard time was this one, number 7. You know what? I don't know if I did it right.
Did you get 7 wrong?
I haven't put it in yet, but I don't know if I calculated everything right because it asks for like how many pairs.
Oh, let me share my screen then because I already took it and I got 100.
Okay, let me stop.
Okay, so you can if you haven't tried, you can just fix it out. I'll explain to you what I did.
Okay.
So where they come from, the answers come from.
Okay.
So what should I do now? I'm scared. Okay, so the green button.
Yeah, green button in the corner. We'll be fine.
Just let me know when it's working.
Yeah, you're good. I can see myself on my phone.
Oh, okay. I hate that when I can see myself. Okay, so question 3. In an ANOVA hypothesis that we reject the null hypothesis when there is sufficient evidence to indicate at least one mean is different from the others. And that is in the book.
Yeah, I found that in the book.
So let me just open it really quick.
Sounds good.
Math. Content. So did you get to figure out the last week quiz where we Excel, but we didn't get the answers right?
Right. So I kind of emailed Sister Cook, and I actually found out how to get SPSS. Okay, it was the weirdest thing, but you don't need it, she said. And so
yeah,
after I figured it all out, I was like, oh, cool. I didn't really need it, but whatever. But I figured it out because I went through some of other groups' videos, and then I went back and looked at some notes and stuff. And it's kind of weird. Like to figure it out, you have to figure out the margin of error for a 95% confidence interval. You have to take the confidence intervals, the upper one and the lower one, and you have to subtract them. So say you have a negative in the lower, and you have a positive in the upper boundary. Take the upper boundary minus minus, which would make it a plus. So if it's a negative, it's going to be a plus. So if it's like 5.678 or whatever minus a negative 2.666 or whatever, well, you actually have to switch it and make it a plus. It's like regular, like mathematics or whatever. So if you have 5.66 plus minus 2 negative whatever, it's actually 5.66 plus 2.77 or whatever number it is. And then you divide that by 2, and then that gives you your margin of error for 90%.
Let's do this. Let's do it together. But let's go through the quiz first, and then we can do that really quick.
Okay.
I won't keep you up. I promise.
Okay.
Okay. So question. So this one was in the book. Question 5. To check if each group is not do the following.
Right.
Chart the QQ plot for each group. Do you know how to do this?
I do.
Okay, I'll let you share now.
Okay. I'll show you how to do a QQ plot. All right, it's kind of weird.
I didn't know how to do it. The way I figured it out is I just went through the means and I saw there were just like, okay, they're kind of like normal. But I didn't know how to construct the QQ plot.
Okay, and that'll help you knowing if it's normally distributed. Let me, I'll share my screen really quick if you want
to. Okay, but I have to stop sharing. Okay, you can go for it.
Okay. All right, put this down. Okay, so here's some data. It's called shot. It's the soccer shoes data that we got that we're using for the quiz. All right. So what I like, I don't. It's kind of weird how you do. So there's always there's these different categories. These have 6 categories. So there's a lot. But when you're doing QQ plots, you have to do everything individually. So for column A through B, like we'll just go here. We'll just use this data. And so what I do is I just copy this, come over here, and I paste it. But then you can go up here to I just have it. Okay, here we go. So under data, there's this little bar up here called sort. So you want to sort this data, and what will come up on the screen is it'll say sort by column and then cell values or smallest to largest. And so what I do is I want it smallest to largest. So I'll just do that, and it'll sort all my data from the smallest number to the largest number. Okay. And what I'll do is I will again go up here and copy this data because this is what I want that I want to be able to check the distribution normally. Then I go to the quantitative descriptive statistics one. You know, it's the first one in the book. Let me show you in the book really quick. So in the book right here, I think. Okay, so when you go down in the book in the chapter, it gives you an option to pick open the file, quantitative inferential procedures. You can click on this, and then it'll bring up help Excel tools, and then you choose when you want to because the QQ plot is under the unit number 1 file of the quantitative descriptive statistics. So you click on that, and it'll actually have you download it. I already have it, but what will come up is this right here. So it'll have the histogram and the descriptive stats, and then on the QQ plots, and then it tells you the version or whatever. It's not really like relevant or anything like that. So you get this QQ plot that's already automatic for you. And then that data I just copied that was from smallest to largest, you put it in there, and then it'll show you the distribution of the data. That makes sense.
Okay, now, and then you did it for the 6 groups?
You can only do it for one group at a time.
Oh, that would take forever.
It does. It takes a long time.
Okay, try again the second time, and I'm gonna take notes of what you did.
Okay, I'll start over. I'll start over from one of it.
You did the whole thing.
I'm gonna go into my statistics. Over. This is my
That was group A. Now you do group B. Group B.
Okay, so if I do group B, I think you can actually just do it right here. Let me just see really quick. So you can just do group B, and then you can sort this.
Sort.
Okay, it'll say sort warning. I don't know why. I usually just continue with the current selection I've already selected, and then I sort it. So column B, cell values. You can choose your cell value. You want to choose cell values, of course, and then smallest to largest.
Values. Sort
Column B on cell values.
And then order smaller to largest.
Yep, you'll push OK, and that will sort all your data from smallest to largest.
Okay.
You see 25 to 41, right? And so I will take this and I will copy this data.
Okay, and then you go to the link in the book.
The link in the book under Quantitative Descriptive Statistics 1.
And click on Kids.
Click on that. It'll download it for you, of course. And so it'll when it comes up, it'll look like this with the histogram on it. You want to go over to QQ plots. And then you click in this. You click on in cell A. Right? Well, it's in column A in cell 2 or whatever. So you go ahead and just paste that data in there, and then it'll give you your data on the QQ plot.
Okay. Okay, so I'll share my screen now.
All right.
Thank you.
You're welcome.
Go here. Is it working?
Let me check. Yep, you're good.
Number 5, since I didn't know how to do that, I just went to the means in the Excel, and then I saw they were like, I don't know, like 20.3, 20.2. So I noticed they were really close, and then came to the conclusion they were normal.
Right.
We assume the variance in each group is equal to the following happens. The largest variance is less than 4 times the smallest variance.
Okay.
So, right here. Is this the right chapter, 14?
Yeah, this is right.
Okay. So the largest variance is less than 4 times the smallest variance, then we will conclude that the variance are equal.
Okay. Yeah, I got that one too.
And then 7, I got 6.
So how did you know that was 6?
Is this the one you got wrong?
Yeah, this is the one I got wrong.
Oh, so
I was trying to figure it out, and I was like, well,
I just did simple math. So look.
Okay.
I wonder if I can do Microsoft. I show you. I'll show you. Since you've been so helpful, I'll show you. Okay, so here you have it. I'm gonna put big letters so you can see what I'm gonna do. So in the first example says that you have 1, 2, and 3, and then you want to pair them, right? So you have 1, 2, you have 1, 3, and then you have, so you have 1, 2, 1, 3. Then I go to the second number is 2, 1. 2, 1 is
And then two, and then 2, 3.
and I go 2. I don't have that one. 2, 3. And then I go to the third number,
Okay.
3, 1. I already have it, which is 1, 3. And I go to the third number again, 3, 2. And I already have it, 2, 3. They're using different number, right? So it has 3 groups right there, right? So the question is saying that you have 1, 2, 3, and 4. So I did the same thing. I did 1, 2, 1, 3. And then I went with the 2. 2, 1 is already there, which is 1, 2.
Oh, okay.
I went 2, 3. So I added 2, 3. And then I went 2, 4.
Okay.
2, 4 is not there, right?
Yeah.
Is that how I got it? Now I'm doubting myself. And then I went 3, the third number is 3, right? So I went 3, 1, 3 there.
Okay.
3, 1. And then I went 3, 2, right here.
Uh-huh.
I went 3, 4.
But there's no
It's not there. So I added.
Oh, that's how you get it.
And then I did 4, 1, 4, 2, right here. 4, 3, right here. That's it. So total 1, 2, 3, 4. See that?
Yeah, I see what you're saying. That's a lot easier than trying to just figure out in your head. Because that's what I was
like, why are they always? That's like tricky math question. So I just did it like that, and I got it right. I didn't even know if I was done. If you had 3 groups here, then you had 6 here.
No, that's a great idea. That's the best way I think to do it. I think that works for me. So, that's a good tip. Tip to have.
Okay, so in this one, we just download the document.
Right.
For the first time, it was exactly what it was there in Excel. So 27.208, 9, 53, 158. The variance, equal variance is satisfied. And then I went to the book. It is satisfied when the largest variance is less than or equal to 4 times the smallest one. So when I went to, this is the largest, and this was the smallest. So when you multiply this by 4, by far than this.
Right.
So then you can conclude that they are equal. Here again, I did the same thing because I didn't know how to do this. Control the QQ plot for each of the 6 samples. I just looked at the means and similar, so that's how I determined that they were normal.
That makes sense.
They keep what the mean, right? It's just the mean, so you cannot know one is really off. Anyways, I don't know.
I can see that.
If you perform another test, question 12, you will observe that the p-value is 0.081. Remove the soft data and text again. So I just delete that column, the very last column, and then the p-value was 0.309 when I removed
Oh, okay.
the
That would
last
change the
column.
p-value. Okay.
Did you get this far?
No, I haven't got this far yet, so I'm just kind of.
Oh, okay. Those right here. So that's 7. Now with 8, uh, it's easy. And then she's opening there. And then here I'm gonna need data files, chapter 2 here, and we'll open that too. Okay, still opening, thinking. There. Perfect. Okay, so here I go here. It's in English. I call it ANOVA.
Yeah, that's what I would say.
Okay, and I delete the data here. Yeah, I know there must be a faster way, but I don't know how to do it. Okay, so if you go to this document, this is this soccer shoe. We're in the soccer shoes one, right? Yeah, soccer shoes. What is the minimum? Okay, so you go.
Sock. Yeah.
Yeah, this is the right one, right? Then I copy the A group, copy, and then paste here. You already asked that and he said yes. Okay. Okay. Yeah, that's fine. Okay, and then B, copy, and then paste right here. And then 3, you know, of course, you have to know how self by doing this all by myself. So I'm enjoying it. So right here, paste, scripty, almost there. Copy, almost there, paste, and then
It's already on.
E, copy, and then last one, stop. The last one, stop. There. And now,
Okay. I see you got that one.
so the question, what is the minimum variance for the 6 groups? And 27,208. Right here. Can you see it? Variance and then 27,208. Okay, so and then the biggest one would be this one, right? 53. 8. So you find that data, that's how you say data right there, 53.158.
Questioning.
Equivalence is satisfied for this data. True. Same thing, if you multiply that by 4, if this number is smaller or equal to 4 times this number, anyways, it's smaller. So because it's smaller, then
they're satisfied with data.
yeah, they're equal. Yeah, the variants are equal. And 11, each of the six samples. That's what you did. I'm not gonna do it, but you just copy and paste and do what you did, right? And then that's how you figure it out. But
yeah, just take it out or whatever.
In my example, I just went here to the mean, and then I saw that they were close to each other.
Oh, okay, yeah, I see what you mean by that. That makes sense to do it that way.
Yeah. And then quiz. Okay. From an ANOVA test, you will say the p-value 0.081. So that's right here. P-value 0.08. That's the answer, right? And then remove the SOX data and perform the text again. What is the p-value? Easy, right? So you just go here, delete this whole thing. And then the p-value now is 0.309. 0.309. The test statistic, yeah, 0.309. The test statistic for an ANOVA hypothesis test is statistic. Is the p-value the area to the right or left of the F statistic? So if you go this, so F statistic is right here, right? It's this line right here. And the p-value will be on the right side of the tail.
Oh yeah, you're right.
So look, it says the p-value for the ANOVA test is the area in the right. And it's always right.
Right.
So right.
Okay.
Right. I'm putting it. Okay. And then now with the nutrition, it's my better. This one is not as long, I guess. Okay, what's the way you can delete this in a faster way?
So just highlight all.
Okay, so I highlight the whole thing.
Go up to.
This one?
Here, you see like the delete button on your computer? It says delete. There you go.
Oh goodness, that was easy. Okay, so if I go here, first we're gonna do the squeeze. Let's examine the calories first. So we're gonna do calories first. I go here and then copy, and then go here, paste, B will be meat, copy, here. And then the third one would be, oh shoot, poultry. Copy, paste. Voila, there you have.
Did
So
you
that's the.
con
Hmm?
did you construct QQ plots for all that?
No, I haven't. No, no, I didn't do the. Let's examine the calories first. Construct
The
QQ plots
directions
on
and stuff.
the
I just don't.
of
There's
the
an easier way
calories.
to do it.
I just went there and I did that, and then I look at the means. And one was way off. I wasn't certain about that.
Okay, so you just looked at the means. I mean, that's very
I
good.
did because I didn't know how to do it, so I just look at the
No, but it makes sense. I mean, I think
means.
I
But
word.
this one was off. Look, 118 compared to this one, so I wasn't very sure about it. So I just thought, well, it's gonna keep asking me about questions about how I did my ANOVA test. So I'm that it met the requirements.
Okay.
So I
No, but that
clicked
makes
this one. So the assumptions have been met. It says it comes from a normally distributed population. And we can also assume that the variants are equal.
yeah. Okay. That I see where you're going with that one.
Um, and then, just so you know, when you do ANOVA, these two things always apply.
That's true. They do.
Distributed, and then the variance are
Variance
equal.
is equal.
Uh-huh.
Yeah, because those are requirements for.
One could be an option, but they cannot assume that the variants are equal. So the variants are not equal, then that wouldn't be ANOVA. So that's why I click on this one. You as it was.
Okay. Right.
ANOVA test to determine if the mean number of calories is the same for all three types of hot dogs. You should find that the degrees of freedom are 251. So that's right here. Look at 2 and 51. Can you see it? That's the degrees of freedom.
Yeah. Okay. Okay. I think.
So it's telling you after when you run this test, it shows degrees of freedom, and the F test is 16,074. So that's right here.
Okay. It's 16. Okay. Okay. And then the
Yeah,
p-value is 0.0000.
and the p-value is 0.0000006
Right.
zeros, then
That's what it
3.
says. Okay. Yeah, I can see that.
Okay, so the question is, what conclusion can you draw? We have sufficient evidence. So just by looking at the p-value,
Yeah, you can either know if it's
yes,
greater than or
then
equal to. So if it's
yeah,
less
yeah,
then if it's less than, it's
you reject.
rejected.
And when you reject, an evident. So because the p-value is so small compared to the level of significance, then we have sufficient evidence. At least one of the hot dog types has a different mean number of calories than another type. And then I came up with this, that at least one, because of the way they concluded it every time. They said at least one. Um, So like this one right here, the p-value is smaller, right? So you reject the null hypothesis, and it says there is sufficient evidence to suggest that at least one of them has a mean level satisfaction, has a different mean, at least one of them.
Okay. What's that?
Included the same way. State your decision after comparing this. So this one, the same thing, the p-value is smaller. And then the conclusion was, will you reject the null hypothesis? And then the conclusion is there is evidence to suggest that there is a difference in the mean. At least one is different. Yeah.
I see where you're going. Okay, cool.
Here's the QQ plot again.
But you got it right.
The poultry is the one that, yeah, I got it right. This is the one that was kind of off, you see?
Yeah, you're right, it is.
These two. But look what it says. It says, and I noticed that when I was looking at the means, it said, now let's examine the sodium levels. Construct of the sodium level for each of the three types of hot dogs. You should see that the QQ plot for poultry, which is the third one, suggests a possible problem with normal assumptions. So it's kind of off. The number is off, right?
Right.
These are close. The smaller variance is this number, just is this number. Have the assumption being to use ANOVA. We still need to use ANOVA. Remember what the rule says? The smallest you 4, and you already see, you can already see 7,000 compared to 10,000. If you multiply it by 4, this will be a smaller number, right? And if it's small,
right,
then it is so right here, if it's less 4 times the small variance, then we will conclude that the variance are equal.
okay.
So that's with this
That would be
information.
that.
The assumption because this one is way smaller.
Mm-hmm.
This number is way smaller than this one multiplied by 4. The assumption have been made age group comes from a normally distributed population, even though, right, this one is smaller, or it's like way off.
Okay.
And we can also assume the variance are equal. And remember, every time they're like normally distributed, to be ANOVA, it has to be equal. The variance has to be equal.
Right. That makes sense.
Despite the possible problem with the QQ for culture, we decide to use ANOVA to determine if the mean sodium levels are the same for all the 3 groups for this test. And I think the information they now use is sodium instead of
use the sodium.
Calories late. So you just have to put the sodium there, and then this is yeah, and this is the answer for p-value. So you just data here for sodium.
Right.
Sodium, just copy and paste values right here. And then that is 0.179.
Okay, for the okay, yeah, I see where you're going.
For the p-value when you put the data of sodium in each different group.
Okay.
And in end 18, what conclusion can you
It's greater than
the mean sodium level is the level of significance of 0.05. So since this one is bigger than this, you fail to reject the hypothesis, right?
Right. So they have sufficient evidence to.
Yeah. Can they have the same mean sodium?
So get that one.
Okay, so what was the? We were all confused. That was week not 14 but 13. That's the one. It was just those two last questions. 13 homework quiz 13.
Is that not the one?
Three wrong, and then I did the homework one. It was the same. I couldn't get it wrong. Like I did the Excel and I looked at it and searched as I saw it in Excel, and then got them wrong. So I don't know.
Might have been.
See, I even got it better on the first attempt. Huh? The quiz mission homework. About his so maybe you explain to me what happened that day, then I can figure out the.
Let me go ahead.